Suzanne Kogan-Artizel, PhD student here at Temple under Dr. Long and John Latecki. We have the locally constrained diffusion process on locally densified distance spaces with applications to shape retrieval. Basically, it's given a database of shapes and then what's called a query shape, say such a horse. Can you look at the database and find the top 40 horse results? Our first contribution is the underlying manifold, the shape of that's by, what am I trying to say here? From the database, what represents the shapes is often very sparse because there are infinite number of horse shapes, but we only have, say, 20 horses to work with. So our first contribution is trying to make more horses in our database. For that, we introduce ghost points. These are synthetic points that are added in distance space as opposed to feature space. And we are able to theoretically prove that these points that we're adding in distance space, therefore they have no coordinates, but are real points in the distance space that we can still maintain the distance to every other shape.
So was the distance space diagram was used to remove the functionality of the image?
The distance space is because we compare the shape of every, we compare the distance of every, we create a distance matrix where we compare, calculate the distance between each shape against every other shape.
So the functionality of the image is not of the issue in the recognition.
Exactly.
Thank you.
So then, once we've densified the distance space, I'll give it over to Shane.
What do you do?
Okay, I'm also the PhD student for the Long and John Latecki. I will just present the second part. After we densify the distance space, we need to propagate the similarity from the query to the other shapes. What we observe, like the original diffusion process, can propagate the similarity very well. But the problem is, this method is sensitive to the noise. And our intuition is the continuous neighbors construction, continuous neighbor structure should be robust to noise. So we use this kind of structure to restrict our diffusion. So we only allow diffusion to happen to the continuous neighbors of data points. And then this figure shows like our intuitively the linear growing is better. So we show that our method is more robust to the noise compared to the original diffusion. And then we use our locally constrained diffusion process on the densified distance space of the shapes, and then we can get our results here. This curve is our result, which is
the red one.
Yeah, the red one is the best at that time, and this is the statistics here, which is the best time. And this blue curve shows because shape retrieval should be unsupervised, but at that time we want to show what will happen if we give some supervision. So this is the results is the supervision, and it can be
obviously supervision is better.
Yeah, but it's just to show that.
Yeah.
So this is our results here. And this graph just shows like whether our method can be harmful, because we only show here that it is always positive results. This one shows the accuracy gain for each class, because in our database we have 70 classes, and this is the accuracy gain for each class. You can see one class going down a lot, the accuracy. This class, because it's the spoon, it's very similar to other shapes.
Right.
In the database, which makes the diffusion somehow confusing.
Right. There's ambiguity in there.
Yeah, that's the reason why it's going down. But most of them going up. This shows our method is how safe.
Isn't that as a data dependent, right? It depends on the image library and the object that you're comparing to.
If all the shapes in the database are very similar to each other, then our method, I think, is going down. But generally, when the database is constructed, it's not that case, so our method is very helpful.
All right, 50 seconds. What are the potential applications?
Potential application is like what Susan introduced before, like Google things. If you draw a sketch and then input into the system, ideally our algorithms can get all the images out instead of just typing the text.
Thank you.
Thank you.